In problem 2 from section 4.4, this is the word problem. The quantity in grams of a radioactive substance present after T years is this thing here. Find the rate of change of the quantity present after 2 years. So again, keep in mind what this function is telling us is the total amount of the quantity of the substance that is left after whatever T years. Okay, so if you wanted to figure out how much of this quantity is left, after 10 years, you plug in T, find Q of 10, and figure out what that is. All right, so the question actually is asking for the rate of change of this, so that's Q prime. Anytime you see the words rate of change or rate at which something is increasing or decreasing or something like that, you know you're looking for a derivative. So for the derivative here, again, this is an exponential function, so first thing we'll do is just copy it to find the derivative anyway. And then we look up here in the exponent, we take the derivative of what's up there. That's just the constant times t. Its derivative then is just the constant. So we're going to get that for our derivative. Let's simplify this a little bit. We'll multiply the 0.421 and the 100. Well, actually, that's just going to be, I'll move that 2 decimal places over, so I'm going to get 42.1, actually negative 42.1 e to the power of negative 0.421 t. The question is, find the rate of change of the quantity after 2 years. So what we're going to look for there is Q prime of 2. That means I just want to plug in 2 into this function, so I get negative 42.1 e to the power of negative 0.421 times 2. Plug that into the calculator. We get, let's see, negative 42.1 times e to the power of negative 0.421 times 2. And that gives us negative 18.1. Negative 18.1. Okay, and the interpretation of this, we could say that at 2 years or after 2 years, it doesn't ask for the interpretation, but it's always good to try to interpret what's happening. After 2 years, the rate of change of the quantity the rate of change of the quantity of the material or the substance is negative 18.1, and let's see the units on here in grams, and that's times, the time is in years, so this would be grams per year. In other words, once 1 or 2 years have passed, we can expect that the rate of change will be 18.1 grams per year, meaning that if it were to continue at that rate, we would expect that after another year, the quantity will have shrunken or decreased by 18.1 grams. Of course, it's not going to stay at that rate. This is just going to be at 2 years. We'll find that if we plug in like 3 years, that will have changed. So we're just looking at this moment in time right at the 2-year mark. It is changing at a rate of 18 grams per year. It's decreasing at that rate. Okay.